Alright guys, CBA 5 review, part 3 should be our final part. We left off on number 10, which we had to find the area of this guy, right? He's a regular polygon, he's a 1, 2, 3, 4, 5, 6, he's a hexagon, right? Which means we gotta do the dreaded apothem, right? Let's draw our apothem there. Let's erase this here. So, remembering that the area of these guys is that 1/2 apothem times perimeter, right? Perimeter we can find no problem because we have one side, right? And it's a hexagon. So the perimeter will just be 8 plus 8 plus 8 plus 8, 8 times 6, right? So we can find the perimeter, no problem. The problem is that apothem guy. Now we gotta find this guy, right? And that's what takes a little bit of trig. Okay, so we learned that first of all, this whole side is 8, right? And this apothem, it bisects this side. So this side right here, it'll be 4, right? And then we can set up this triangle here with this, right? And this was a radius, called a radius of this guy, right? So we can set up a right triangle, right? And we have a 4. We can solve for the apothem. Only other thing we need is an angle, okay? And I always like to look at the fact that all of these central angles, right, because all this is 360 degrees, right? So the central angles here will be 360 divided by 8, because we'll all be, or 6, sorry, 6, because it's a hexagon, divided by 6. So they'll all be the same. They'll all be 360 divided by 6, or 60 degrees. 60 degrees. So if that's 60 degrees, well, this thing is 1/2 of one of those. So this right here will be 30 degrees. Okay? Okay. So now if we know that this angle right here is 30, that this side is 4, well, we can use trig to solve for that last side. So I'm going to redraw my triangle, just my right triangle. Just this triangle, I'm going to blow it up over here so we can see it a little bit better. Don't make fun of me because my triangle isn't going to be perfect. That ain't too bad. So we got this right triangle. We know that this angle up here is 30, right? We know that this side is 4, and well, we want to solve for this side. Okay, so back to some of our trig stuff, right? This is the angle we're looking at. So this would be the opposite side, right? This is always opposite of the right angle is the hypotenuse. So that leaves this side to be that adjacent side. So we're going to use the trig function that uses adjacent and opposite, and that's TOA, right? TOA, or tangent. So tangent of theta equals opposite over adjacent. Okay, well, theta is just always our angle, so it's tan of 30 equals, and now opposite is 4, adjacent is x. Okay, so we can put this guy over 1, do our cross multiplication, right? This guy and this guy. So 1 times 4, that'll just give us 4. And on the other side, we'll have tan of 30 times x. So then our last move is to divide by tan of 30 on each side. Okay, divide by tan of 30 on each side. So what we're left with is, this tan of 30 and tan of 30, they're going to cancel, make 1. So we're going to have x equals this stuff right here, 4 divided by tan of 30. So then the other part of that is being able to put that in the calculator. So let's just look at our wabbit, and I'll remind you of how to do this guy in the calculator. Let's make him, oh no, don't x. Just want to make him a little bit bigger for you. There you go. So let's turn him on. He's still there from a calculation we did a while back. So looking at our calculator, we always got to go to mode first. Hit this mode button. Make sure we're in degrees. I'm not. Boom, that would have messed me up. So we got to put him in degrees. Okay, and then we can go second mode. That'll quit. That'll get you out of it. Okay, and then we can put this guy in just like he is. So it's 4 divided by tan of 30. Just like that. 4 divided by tan of 30. And we should get a not so pretty number, right? 6.2, nope, excuse me, 6.92, right? 92, we'll call him 9.3. How about that? 9.3. So over here, back over here, x equals 6.93. 3. Okay, and it's not just any x, right? It's this side of the right triangle. It was this side of the right triangle. Okay, it's our apothem, right? It's our apothem. So that's what we need to now solve for our area of this whole regular polygon. I know these problems are long, like 12 steppers, but they're not too bad. So then area equals 1/2 that apothem, which we just found to be 6.93 times perimeter, right? And we got one side right here is 8. Well, this is a hexagon, a regular hexagon, so they're all 8. So it'll be 48, right? 8 times 6. So the perimeter will be 48. So then we can find that our area equals 166 I can't remember. Let me scroll up and see what the problem said. Round to the nearest 10th. I know yours don't look like this. I deleted the figure on number 9 so I'd have more room. Round to the nearest 10th, so 166.3 centimeters squared. You might have found a little bit of a different answer because there's a bunch of rounding and different stuff that goes on in these problems. That's okay as long as, you know, our CBA is going to be multiple choice. So if you can get close enough, then you'll be able to pick the right answer. You might have got a little bit different. Don't freak out if you did, okay? All right, so boogieing down to number 11. And I'm going to have to erase a little bit of the old problem we wrote over our guy. All right, so it says state whether the figures have line symmetry, rotational symmetry, both or neither. So looking at the first one, as far as line symmetry goes, right, there's on these parallelograms like this, there's not going to be any line that I can draw, right? If I folded that guy over that vertical line there, notice that point will kind of go over here, and it wouldn't be a line of symmetry, so don't get that confused with a line of symmetry. And same thing, and I'm sorry that's not perfect, that's a real ugly line, but if you fold that guy over that line, right, again, it's not gonna fold into the same image, right? It's not gonna be the same image on the other side. This little point is gonna kind of be over here in no man's land, right? And then even same thing if you we're thinking kind of diagonal, and that's a real ugly line too. But if you fold it over that diagonal line right there, also the same thing. This guy isn't gonna have any lines of symmetry, okay? But if we drew a point right in the middle of this guy and we rotated around this point, once this guy got back around to here, and this would probably help with the patty paper if you're not seeing it, but this guy will have rotational symmetry. Once you rotate him 180 degrees, he'll be back to the same image, right? And as long as he goes back to the same image before 360 degrees, between 0 and 360 degrees, if it goes back to the same image, it's said to have that rotational symmetry. So this guy actually will have rotational symmetry. Okay, so for our next guy, back to the line, talking about line symmetry, this guy will have line symmetry, right? We can draw a line right down the middle of this guy, and if we folded him over that line, he'd be the same image, right? He'd be the same guy. So this guy does have line symmetry right there, and he actually has line symmetry also vertically. Some of you probably seen vertically. This guy has line symmetry. You could fold him over again, and he'd be the same guy. So yeah, he has line symmetry for sure. But this guy also has rotational symmetry. If you drew a point right in the middle, right, and you spun him 180 degrees, right, he'd turn back into that same guy. So this guy's pretty cool. He's gonna have both line symmetry and rotational symmetry. Okay. All right. So one more of these bad boys, and let's read it. And it says, what does it say? It says a billiard ball set contains 16 spheres. So we're talking spheres. Okay, and each 2.5 inches in diameter. 2.5 inches. Whoa! 2.5 inches in diameter. Okay. What is the total surface area? So the total surface area of the complete set of billiard balls. Okay. And it says round to the nearest, thousandth of a square inch. Thousandth. So it's not the 10, it's not the hundredth, but the thousand. It's 3 decimal places. Going to be very exact here. All right, so we want to find the surface area of these guys. I'm just gonna write surface area like this. So we're talking about spheres. So surface area of spheres are 4 pi r squared, and that's just the formula for surface area of a sphere. So it wants us to find the surface area of the complete set of billiard balls. So first we'll just find the surface area of one using the diameter given here. We'll find the surface area of one, and then because there's 16 of them, we'll just multiply that answer times 16. Okay, that's all we'll do. We'll just find the surface area of one and multiply times 16. So now the surface area for just one will be 4 pi. And notice here they give us the diameter. Be careful, they give us the diameter, so don't put that in for the radius, right? The radius is going to be half of that diameter, so it's going to be 1.25 squared. Okay, so we'll find that this guy has now a surface area of 19 point, and we'll do 0.63 is fine. 19.63, and that is, we're in inches. Yep, inches, and it's the surface area, so squared. But remember, that's only the surface area of one, so that's not going to be our final answer, right? Because they want 16. There's 16 of these balls, and they want the total surface area of the complete set of billiard balls. So they want all 16 of them. So then we just got to take that 19.63 and multiply by 16. Okay, so for our total surface area, it's going to be that 19.63 times 16 of those billiard balls. So now for our final answer, the surface area will be 314 point, well, it's only 2 decimal places, 0.08. Sorry, they wanted to 1,000, it just went to 0.8, so it's exact though, so that's okay. Okay. So again, there's some rounding that went on there, so you might have found a little bit of a different answer, but that's okay. We'd be able to pick it on a multiple choice CBA. Alright guys, there's your CBA review. Study hard. I think if you can do everything on this review, if not only you just follow along with what I did, but if you understand it, I think you'll have what it takes to do great on the CBA. Good luck.